All right, guys, let's get ready for the Unit 4 test. So a big part of it, to start with, is standard algorithm of multiplication. Remember, first we're going to multiply with whatever's in our one spot here, which happens to be a 7. So 7 times 4, then 7 times 5. 7 times 4 is 28. So we have to carry our tens digit over. They already have the 8 there. And then 7 times 5 is 35, 36, 37. I had to add those extra 2 because whatever we carry over, we just add. So we're done with multiplication around 1. Next, we're going to have to place a 0, but they took care of that for us, so that's good. And then we're going to multiply again, this time with whatever our tens digit, the next number. So 6 times 4 is 24, so we're going to carry the 2 over, and the 4 they already wrote for us. So again, 6 times 4 was 24, carry your 2, our 4 goes there. 6 times 5 is 30, 31, 32. So again, we had to add whatever we carried over, done with multiplication around 2, and then finally we're just going to add these up. So 8 plus 0 is 8, 7 plus 4, it gets us to 11, 3, 4, 5, 6, and then a 3. So 3,618 is what we're looking for. And that's it, guys. So again, on these where you have to fill in the missing parts, just start from scratch. Heck, if you want, rewrite it over here and just do the whole thing. But that's all we're doing. So do it again. So again, we're going to start with multiplication. Again, in this case, it's the 2, whatever's in the ones. So 7 times 2 is 14. I'd carry the 1 over. 8 times 2 is 16, plus 1 is 17. So we are missing 7. And then 2 times 3 is 6, plus 1 is 7. Sweet. So we're good there. Next, we got to place our 0. This time they didn't do it, so we have to put our 0 there. And then next, we're just going to multiply again with whatever is the digit in the 10 spot. So 7 times 7 is 49, so they have the 9 there. 7 times 8, that's 56. 57, 58, 59, 60. I carry my 6, but they do have the 0 from the 60. 7 times 3 is 21, plus 6 more. Well, 21 plus 6 more. 6 plus 1 is 7. So we get 2790. 27,090. Done with that. And then again, we're just going to add these up. Get a 4, 16, 7, 8, and then 27. So 27,864 is what we're looking for on that. And we're done with the addition. Next, we have to set up our own problem. Use standard algorithm to find 25 times 488. And we have talked in class, if we have a 2-digit by a 3-digit, it's a little easier. Just put that 3-digit up top. So the larger number up top, so 448 times 25. And actually, you know what? Let's not use blue. I'll keep the same color patterns. Let's write it in. And we'll go brown, why not? And I guess we don't need so thick. So 448 times 25. All right, so in blue, again, we'll start with our multiplication, round 1, which is a 5. 5 times 8 is 40. 5 times 4 is 20, plus 4 gets us at 24. And then 5 times 4 again is 20, plus 2 is 22. So our first partial product should be 2240. Next, we got to place our 0. And I'll just cross these guys off so I don't get confused later. Next, we're going to multiply again, this time with the 2. So 2 times 8 is 16. 2 times 4 is 8, plus 1, so 8, 9. So we got to put a 9 here, because we had the 8 plus the 1 more. And then 2 times 4 is 8. Cool, done with that. And then finally, we're just going to add these up. So we get 0. We get a 10. So we got to carry that over. 9, 10, 11, 12. And then 10 plus 1 is 11. So 11,200 is what we're looking for on that one. All right, number 3, we're finding a fraction of a number. In this case, we're looking for 3/4 of 48. And in class, we talk about, well, what's 1/4? If I can find one unit of a number, then I can multiply it by how many I need. So again, if I, just a little visual here if this helps too, if I take 48 and I cut it into fourths, what I need to do is find out how much 1 unit is, and then I can have 3 of those. So really, we're going to start with what is 48 divided by 4. And if we know our facts, we should know that's 12. So in other words, there are 4 groups of 12 inside 48. So that's 1/4 of 48. But if I want 3 of those, now we're going to do that 12 times 3, and that is indeed 36. Okay, so 36 is what we're looking for. You don't have to draw this picture every time, but just kind of giving you a little visual. And then this time we just need 1/4 of 64. So what is 64 divided by 4? So again, we can think about this as 64 divided by 4. Maybe we'll go this route, practice a little standard. 4 goes into 6 one time. 1 times 4 is 4. Subtract, we get a 2. And then we got to bring our 4 down. So bring the 4 down. And 4 goes into 24 6 times with no remainder. So we're going to get 16 on that. So just if I need 1 unit of it, just what's 64 divided by 4? 16. So if I did want to think about it this way, again, that tells us if I have 64, I'm going to have 4 groups of 16 inside that 64. Cool. All right, true or false? And again, we do want to explain our thinking on this. Maybe you need to solve all these. Maybe you kind of have some ideas. We could write a sentence. But let's just kind of see what we want to do on each of these. First one, 32 times 4, is that the same as 1,280 divided by 10? Well, first of all, if I'm dividing by 10 with a 0, anytime I divide by 10, I'm just kind of moving my decimal over. So that means I'm going to get 128 on this side. So we get 128 over here because we're dividing by 10. So we just got to see, well, what's 32 times 4? And again, we can kind of just do a little standard here. 4 times 2 is 8. 4 times 3 is 12. Hey, we got 128 equals 128. Therefore, it's true. And maybe you did 4 times 3 is 12. So 4 times 30 is 120. Plus 4 times 2 is 8. But either way, we can prove it. Cool. How about the next one? 342 times 28, is that the same as 3,828 divided by 3? Again, I'm going to look at the division first. Let's see. Just kind of a rough estimate. This is going to be a little more than 1,000, right? If I have 3,000 and something divided by 3, that's going to be a little more than 1,000. So let's kind of start there, see if I need to do all this work or not. Now, if you want, you could do the whole division real quick, but I'm just going to kind of, and then, let's see, I'll kind of group my work here. That's for A, B, let's see. So if I do the 342 times 28, 8 times 2 is 16. Let's see, 32, 33. And then 24, 25, 26, 27. Okay, I gotta place my 0. Don't need these. 2 times 2 is 4. 2 times 4 is 8. And 2 times 3 is 6. So we got our partial products. So we get a 6. 3 plus 4 is 7. 14, 15. 8, 9. 9,576 is nowhere near about a little more than 1,000, right? So if we get 9,576, you don't even have to figure out what that is. We know it's not even close. So that's not going to be the same. So that's going to be a big F, big false on that one. And again, if you wanted to solve that whole thing, you could. But once you know it's true or false, as long as you can prove it, you're good. Let's see this next one. 58 times 99. Is that going to be the same as 4,897? Well, one strategy we talked about, you could do standard algorithm, Or you know what? 58 times 99, that's a lot like 58 times 100. And then just minus a group of 58, right? So that'd be 5,800 minus 58. Okay, do a little regrouping here. Got 7 left, 9, 10. I can kind of zoom in a little bit here. So again, we got 7 left. That's 10 for a second, but we got to take one to make that a 10. So 10 minus 8 is 2. 9 minus 5 is 4. We got 7 and a 5. So we got 5,742. That is not the same, is it? So in other words, 5,742 is not the same as 4,897. So that's going to be another false on that one. So part C. And then D, well, just multiply these out. Let's see. 480 times 25. Let's see, is that going to be 12,000? And actually, you know what? I might use a double and half strategy. We talked about this earlier in the year. Just to kind of review a little bit. Let me make a little more space here. Get rid of you. Don't really care about this. Let's just review that double and half strategy real quick. Or you could do standard, but I'm going to, let's see, so if I got 480 times 25, I can double 25 and get 50, and double that to get 100. Now I got to cut 480 in half. Well, half of 48 is 24, so it's going to be 240. Half of 240, well, half of 24 is 12. So what is 120 times 10? Well, right, 120, add 2 zeros. Hey, looks like, yeah, that does work out. So yeah, so we do get 1,200 on both sides. Or 12,000. We get 12,000 on both sides. So that is true. So again, if you need to figure all those out, or just kind of walk through, once you have some way to verify, you're good to go. All right, and then we get to our ratio tables, the other big idea from this unit. Matthew wants to build some craft stick birdhouses to sell at the fairs. Now each birdhouse costs $350. Use ratio table to find out how much it would take to make 21 birdhouses. So we got to figure out 21. So I mean, somewhere up here I got to have a 21. Okay, well, if we know 1 is 350, you know, we could double that, but I think if I go to 10, it's going to help me a little more, because I know 350 times 10 would be $35. Because again, we just move our decimal over 1, and we've talked about that in class. Now, you could fill up as much of this ratio table as you need. But yeah, so once I know that 10 of them will be 35, because what did I do? I just multiplied by 10. Multiplied both these by 10. Now to go to 20, I can just double it, can't I? So I could double that. So guess what? I got to double my 35. If I double their 5, we get 70. And then to get 21, well, I only got to add one more, right? So that means 70 plus 350. That 21 is going to be that 70 plus the 350, that one cost. So we're going to have the 50, looks like 73.50. So again, you can set your ratio table however you want. I'm looking at the answer key just as we're going, make sure I'm on track. The answer key said 1 birdhouse was 350, 2 was 7, 4 was 14, 5 was 17.50. Personally, I don't really care about most of that because I know I can go to 10, double that to 20. So it's all about how the students want to set up these ratio tables. But we do want to get to our answer, which is 73.50. However you want to get to it. Now the opposite kind of, what if we have a certain amount of money? So what if we have this much money, $346.50? How many birdhouses could we make? So again, at some point, we're going to need to have 346.50 on the bottom here. Well, let's keep this. I think let's keep the same idea. For me, let's go with 10 again. Again, if I multiply by 10, that's going to be that 35. So 10 birdhouses cost $35 to make. Well, what if I multiply by 100 actually? I could do 10 times 10, or what if I start kind of over again? What if I want to know how much 100 birdhouses would cost? Now we're going to move that decimal 2 places. So if I move it 2 places, 1, 2, that's going to be $350. So we can go right to there from there. You know, what if we multiply by 100? Well, that's pretty darn close. In fact, is that one less? So it's going to be 99. Yeah, let's just do a little work here on the side. If we have that 346.50 that they gave us, and then if we add that one more, that 350, 0, 10, 6, 7, 8, 9, 10. Yep, that's how we got to that 350. Whoop. So yeah. So again, the key doubled it to get to 2, then they went to 5, then 10, then it went to 100. So again, it's all up to the students how they want to jump around these numbers. But it's all about having a good understanding of how these numbers are related to each other. And it turns out, yep, we get 99 birdhouses. Okay? That's how I set my ratio table. You don't have to set up yours the same. That's what made sense to me. Last question's got 3 parts. Esperanza is helping her aunt bag some apples to sell to the market. They've got 98 apples, and they want to put 14 apples in each bag. How many full bags of apples will they have when they're done? Now, we talked in class, it says full bags, so there might be some extra apples left over. I don't know. If there are, we're only concerned about how many full bags. Okay, so first let's talk about how could we estimate with this. Well, we do know that we've got, again, 98 apples. With 14 in a bag. Okay. Well, let's say we can make 10 bags of apples. What's 14 times 10? That would be 140 apples. So that's clearly too much. So if I cut that in half, that means 14 times 5. Well, half of 140, that'd be 70. It's getting closer. So there's going to be more than 5 bags. Let's see, if I add another bag, that'd be another 14. This would be 84. So, yeah, I'm thinking maybe 6 or 7, maybe. I don't know. Just kind of based on some rough numbers here. Now we're actually going to solve it. So what do we need to do? We just need to do 98 divided by 14. Well, let's use a little more of this partial quotient that we've learned this year too, because I don't know exactly off the top of my head how many times 14 goes into 98. I can start adding 14 a bunch of times, or let's just review that partial quotient strategy. Now right here, just with laying some stuff out, we know 14 times 5 is 70. So 14 goes into 98 5 times, that's 70. Let's subtract, we get 8 minus nothing. And then 9 minus 7 is 2. Then how many times does 14 go into 28? Oh yeah, that goes in twice, doesn't it? So 14 times 2 is 28. All right, so how many was that altogether? 7. So yeah, it turns out 14 times 7, and we could always check our work too, especially on a test. 14 times 7, we get 28. 7, 8, 9, yep, checks out. And then they just want us to write our answer in a sentence and basically show our work as well. I'll be honest with you, I can see the work here. So, yeah. It doesn't say show our work there. And then just label it with the correct units. It's funny because in the answer key, they showed their work. Oh, no, I need to scroll down. That's what it is. There we go. So what was our answer? Our answer was 7. So how many bags can they take? How many full bags? Yep. They will have 7 bags of apples. So cool, guys. That's what we're looking for. That's it. So standard algorithm multiplication. That was the big thing. A little true and false, just reviewing some basic stuff. And then some ratio tables. That's it, guys. Hopefully we're feeling confident. Let me know if you have any questions.